eyeball icon. And what we can do now is we can hover over one of the vertical corners of this right here, and we can double middle mouse button click. And that is going to select all of the vertical edges that are kind of in a ring around this object. This is called a ring selection. So we're going to double click on that. We can see now that all of the edges that kind of follow this around, not up here, but all of these vertical edges that kind of follow around this box are now all selected. And that's going to be really important for this next step. I'm just going to hit Space G to kind of reset our view here. And what this is going to allow us to do is divide those edges. So we're going to use a node called edge divide. So while we're over the viewport, I'm going to hit tab and type edge divide like that. Hit enter. And now we've dropped down an edge divide node, and we've also moved our display flag down there. So let's look at some of the parameters we need to set here to make sure that we're getting the right geometry added. You can see that there aren't any edges built or any edges added yet. So let's first change our divisions to 3. We want to have 3 divisions. So we're going to have 4 panels, or sorry, we're going to have 3 panels that way. And we're going to also need to check a couple boxes here. So we're going to say connect points, because right now, if we turned our point display on, we can see that there are these new points here, but we haven't actually connected them. So let's connect the points like that. We can see that they now start to go around most of it, but we see there's a little gap here. And so what we want to do is just make sure we close the path, and that's going to make sure that those loops go all the way around. And now we have some geometry here that we can use to create some slats from. And what we're going to do is we're actually going to extrude those slats back outwards and make them look like they're kind of like panels on the side. So that's the next step we're going to do. So we are going to select edge divide here. We're going to click the output dot of it and hit tab and do poly X again. And let's name this one also just to make sure that we know what's going on here. And this is going to be extrude slats. And within our group selection, we can actually select one of those groups we made much earlier. Oops. Looks like we got a little error coming there. Interesting. So with this, we can use one of our groups. And we can come up here and we can select create panels. And this is going to be these side panels still. And even though we divided them, Houdini was smart enough to know that that's still what that group is. So if we come back up here to edge divide and look at this and click on our eye icon here and we say create panels, we can still see that these sides are, even though they're 3 polygons now, they're all into that create panel group. So it's smart enough to know that we split a polygon. We want to keep that entire polygon, original polygon within that group. So just a little thing to kind of keep in mind there and maybe explain to your students that that's what's going on. Also, if you have this up, you can just click this little icon here to turn it off. Or we could have gone back into our eye icon here and just made sure that this is off as well. So a couple different ways to turn that off. All right, so we've got our extrude slats. So now let's actually start extruding those. So we have a distance that we can go here. And let's see, that's going to be just a really small extrusion, 0.0125. And that's just going to give us a tiny little extrusion, but we can't actually really see what's going on there. So we're actually going to combine an extrusion with an inset. And this is going to push it out and also kind of taper the end in a little bit at the same time. So we're going to just do a very, very small inset. We'll do 0.005. And we can now see that we've got a little bit of an inset down here. We can see that's pulling away. It's maybe tough to see, but if you look right there, you can see that there's an inset forming. And from there, we also want to make sure that we have our divide into set properly. And so for that one, we want to change our divide into to individual elements, and that'll make sure that now each of these individual polygons are actually being extruded and inset at the same time instead of the entire polygon geometry that's connected operating as one. So now each of our individual kind of slat polygons is extruding in that way that we want it to. So what we're going to do is we're going to add a group from this extrusion now that we're going to use in the next step. And this we're going to use the front boundary group. So this is going to be extrude front seam. We're going to change the name of that to slat edges, like so. And this we're going to use in the next node to make sure that we're operating on just that one selection instead of going through and selecting all of those slat edges. That's just kind of an unreasonable thing to do and go around the entire geometry and select it that way. So what we're going to do with now is we're going to bevel the edges of those slats. So if we take the output here, hit tab and do poly bev, we'll get a poly bevel, we'll line that up. And what we can do is we can use our group up here and drop down here, and we can see we now have that slat edges that we created in the poly extrude just previously. So we'll click on slat edges, and if we hit enter over the viewport, we'll enter into the poly bevel viewer state. And you can see that those are kind of highlighted in this blue color. So all of the edges that we're going to work on are now in those blue colors. So what we can do now is we can adjust some of the parameters in this to actually bevel those edges. So we, again, are going to need a very small bevel because these are our small pieces of geometry. So the distance that we're going to work on is 0.0025 is about where I found was a good amount for that. Now you can see that we've added these little bevels in here. And what we're going to do is just round those ever so slightly. So we're going to make sure that we add a couple divisions here. So if we add 1, 2 divisions, we now have a little bit better rounded geometry here. If we change it back to 1, you can see it's kind of flat, and the more edges we add, the more round it gets. Again, these are very small features, so we only need a few divisions. We don't need anything too crazy. Because obviously you could think, oh, we want to do 20 to make it nice and smooth. But no, that's just going to really add a lot of extra geometry that's sort of unnecessary. There's other things in 3D like normals and things like that that we can use to smooth our geometry. And that's really not the point of this step, is to make every single little feature that we're going to see. Unless you're really close to it, you can kind of get away with only a couple divisions just to give it the sense that it's rounded. So we have those rounded slats, and the other thing that we're going to do is also bevel the edges of the crates. These sharp edges here are just, I think, a bit too sharp for something that maybe would be made out of wood. So let's go in and bevel those as well. So let's name this first one here to say bevel slats. Again, we have a lot of nodes that are the same, so I want to name these so that we know exactly what's going on here. So 2 poly bevels in a row is kind of hard to know which one does what. So let's click the output, do another poly bev to get the poly bevel node. We're still in our viewer state, so we can see that all of the edges are now selected, which is not what we want. Let's change this to only be working on our crate edges. So let's go back up here. We have our crate edges, and there we go. We only have those edges that we'll be working on now. So these kind of pushed out areas of our crate is what we're going to work on. So let's change, first, let's change the distance to 0.025. Just give it just a little, a bit more of a bevel there so it's smoother. But you can also see that it's now working on these that are down here, and that's really not what we want. We don't want it to be beveling these edges. It's really kind of pointless. So what we're going to do there is we are going to change those by going under the exclusions, and we're going to say ignore flat edges, and we're just going to raise this up a little bit to something like, say, 45. And that's just going to give us a little bit, it's just going to give us some margin to be able to make sure that we get all of our flat edges taken care of and not being a part of this bevel process. So now you can see that just the sharp edges are being beveled. And what we want to do then as well is also change the number of divisions. So these are a little bit bigger bevels. So I think doing something like 4 divisions is going to be better, because you can actually see that quite a bit more than those little tiny ones that were inset here. Honestly, you could probably go up even a little bit more if you wanted to, really depending on how close you're seeing it. But all of that stuff will always take more memory, more computing power as you get further into working with 3D geometry. So the last step that we want to do is just move our geometry up to the XZ plane. The reason for this is that it's just kind of nice to have it where it's not sitting below the origin, so that if you want to place it somewhere, say instance it or do things like that, copy it around in your scene, you kind of set it at the ground plane so that you're not having to do that later. So let's do that last step here by clicking the output dot, hitting tab and doing match size, hit enter. And really what we're going to mainly use this match size for is just setting it to so that the minimum Y position is right at the origin. So we're going to change justify Y to minimum, and that will place us just like that. And that will conclude our process for this lesson. So thank you so much for joining us, understanding a little bit more about how these polygon tools work in Houdini, and helping your students get a better grasp on how to manipulate geometry using Houdini's procedural tools. Thanks so much for joining us, and I'll see you in the next video.